Hello, and thanks for tuning into Futurology, an EarthOne subsidiary. This video is a compilation of documentaries to serve as aid for this channel's Technological Revolution series, which will take us on a journey from the history of humanity to modern-day automation and universal basic income to the future of work, humanity, and more. The reason we wanted to do this is to give further context into many of the concepts discussed about the technological revolution today and their origins, such as automation. Additionally, to highlight a time period where people aspired for a brighter, more optimistic future fueled by technology, as well as so we can appreciate the advances in technology we all often take for granted today. Enjoy the documentary, consider subscribing, and let us know your thoughts on the subject matter in the comments below.
This is automation, today's way of manufacturing. This is the challenge for today, to meet competition and rising costs by moving step by step towards automation, continuous automatic production, including automatic handling, automatic making, automatic inspecting, automatic assembling, automatic testing, automatic packaging of products in one continuous flow. The evolutionary step-by-step development is well underway today. Before the word automation was coined, the idea of fully automatic production suggested blue sky fantasy. Improvements in manufacturing seemed funny or fearful, depending on the viewpoint, and increased productivity, the source of higher wages and profits, was often overlooked. The trouble was that some people thought of automation as a sudden thing, a revolutionary idea. But it isn't. It began nearly 200 years ago, when Oliver Evans put into operation an automatic grist mill. But Evans' basic problem was controlled power. He had to depend on water wheels and gravity. Before automatic could become significant, some entirely new type of power would have to be developed, a power far more flexible than falling water, or even steam. Controllable electric power, which could make automatic production practicable throughout industry, appeared in the 19th century. The step-by-step development of continuous automatic production was accelerated as early as 1919, when automatic blowing of electric lamp bulbs was begun at Pitney Glass Works in Cleveland. In 1938, 5 automatic machines were connected with transfers to form a continuous production line for machining and polishing flat iron castings. The idea of continuous automatic production, of automation, was here progressing from the processing of flowable materials like grain and molten glass to separate items like flat irons. And then, in the late 40s, developments in electric power and control helped to make possible a line for the automatic machining, honing, drilling, and boring of automobile engine blocks. This greatly increased productivity worked to the advantage of everyone, for this company today employs many more thousands of people than it did in 1947. This natural evolution in industry is developing automation as a way of manufacturing that can do much to improve our factories, products, and profits, and upgrade our workforce today and in the years just ahead. Progress in automation comes at a time when we will need it most. The United States, once an essentially agricultural country, has become the world's most important plant for the production of goods, with plenty of room left for food and fiber crops. Each person works for the other. All consume each other's goods and products. Our numbers are growing fast, but our demand for goods is growing much faster. At the same time, business is getting more and more competitive, for if demand is growing, so is supply, as new competitors appear or old ones increase their efficiency. To hold or to build our share of the available market, we must cut production costs by applying the principles of automation. Manufacturing operations can be separated into three broad groups. First is the manual area, where physical effort is used to perform operations by hand or with the aid of hand tools. Second is the mechanization area, where manually operated, power-driven machines with varying degrees of control are used to perform one or more operations. Third is the area of continuous automatic production, where automatic machines are integrated with transfer devices and with controls to perform a series of continuous automatic operations. Materials handling begins in the manual area as a separate operation. In the next area, mechanization of materials handling is introduced. In the automation area, it is an integrated part of all operations. How automatic can we get? Except for process industries like oil and chemicals, the highly automated factory is still far in the future for most manufacturers, and progress comes from finding operations that can be upgraded, if only one step at a time. But the pressure of competition is bringing about step-by-step progress towards continuous automatic production, towards more and better jobs and greater profits. Automation principles, wherever they have been adopted, have proved their value in every way. First, automation pays for itself within reasonable time. Automation increases efficiency. Machines can be kept running longer at full capacity without shutdowns and delays for loading and unloading. Workers are upgraded. The emphasis shifts from manual to mental skills. Automation conserves manpower, a critical requirement as the demand for products grows far faster than the labor force. Automation improves quality by reducing manual handling, and there is greater opportunity for building inspection into the process. Automation increases safety. Machines move and lift. Human fatigue is greatly reduced. Automation reduces in-process inventories by the continual movement of materials. While continuous automatic production has not been entirely achieved, some industries are close to it. Bulb production was once a batch operation, but as early as 1919, development toward continuous flow began. In this glassworks, 46 types of bulbs are produced. Here is an operation high in the automation area. Glass biscuits are automatically produced by pocketed rolls turning against flat rolls. Chain conveyors automatically pass the biscuits to the blowhead. Finish blowing takes place in this rotating two-part mold. Around they go by way of a merry-go-round conveyor, continuously, automatically, on their way to the annealing oven. The plant capacity, through the use of such automation as we have seen, is an unbelievable 1,100,000,000 bulbs a year on a 40-hour week basis. Between 1910 and today, the cost of living index has risen 183%, but the cost of the 100-watt light bulb fell from $1.45 to less than a quarter. If the production methods of 1910 were used today, this 100-watt light bulb would cost over $4. During the same period, the population of the United States increased 80%, while employment in the lamp industry went up over 400%, or 5 times as fast. Here is the product of an automation process that has very wide appeal indeed. Cookies of various types produced in a continuous flow operation. The coordination of equipment speeds in this process from dough to packing is provided by adjustable speed DC motor drives. A cookie is more than something to eat. It is a manufacturing problem that has been linked. The customer is king, and highly flexible equipment is required to give him these very delicacies. This machine can be set for many different varieties, from rotary molded cookies to extruded stock, like fig bars, which are cut after they have left the oven. Since all 4 types may be run in one day, the drives must change speed proportionately. Baking time can be changed, so the requirements for the next run can be met without upsetting relative adjustments on cooler, stacker, and packer for the remainder of the run. For cookies or cars, automation is paying off. The principle of continuous automatic. The blocks, beginning with the rough casting, put automatic in and out of more than 20 different machines, from feed electric drive broaches, traveling 150 feet a minute, through a total of 531 milling, boring, honing, tapping, and drilling operations. Production levels are maintained by specialists who replace all worn tools. In this operation, electric drives and controls contribute to higher production rates at lower production costs. These more elaborate examples of automation demonstrate to what extent the idea of continuous automatic production has been put into practice. It may not be economically feasible for every manufacturer to automate his entire production line, but important cost reductions can be realized by automating parts of a total operation. Few people realize that for all operations, including making, inspecting, assembling, testing, and packaging, the average falls at the low end of the mechanization area. This is the type of manual operation that can be seen in thousands of plants today. And this shows how soon a part manual, part mechanized operation can be upgraded in an automatic press line for producing series of operations within one line is here brought to a high degree of efficiency, as forgings like this are made into refrigerator compressor crankshafts. The forgings shuttle down a chute into the first machine. From this point on, 22 different types of operations are automatically performed in a continuous cycle. Upon completion, the pallets are dumped and returned to the loading station. The crankshafts are then transferred to the final grinding operations, which will result in finished crankshafts like this. There are numerous opportunities for moving inspection operations into the automation area. This manual inspection operation, once the very symbol of precision, is fast losing appeal as those who practice it lose money. Here is a machine for the automatic gauging and segregating of pistons. The pistons enter and are gauged and stamped for pinhole size. Undersize and oversized parts are rejected down a chute. The second station gauges the piston for skirt diameter and taper, stamps it, and transfers it on a belt conveyor unit for segregating into classifications. Capacity of the machine is 1,700 parts per hour. At times, automatic inspection may be combined with automatic making in one machine. This machine, equipped with automatic loading and unloading fixtures, continually measures its own work. When an error is sensed in the machining of a part, the tool is automatically repositioned to eliminate the error. Assembly, even today, is an operation that falls almost entirely in the manual area. But cost-conscious manufacturers in all industries are alert to opportunities for savings through automation. In the assembly of condensers, for example, this winding machine has greatly increased production. Significant progress has been further accomplished with this ingenious inline machine, on which 4 condenser parts, including cans, tubes, spring washers, and windings, are automatically assembled. In another inline operation combining further assembly and testing, each lead is gripped as the assembly passes, and the condenser is tested for capacity. If this test is unsatisfactory, the assembly is automatically rejected. Brass clips are attached, as they are made, onto the lead wires. The clips are then automatically welded to the lead wires. Here, great strides are being made toward the automatic assembly of electric motors. The motor parts are automatically conveyed from different areas of the factory to come together for assembly. The focal point is this assembly machine. The upgrading of the operation for automatic assembly here has helped to double motor production. While most is just stepping into the mechanization area, there has been progress. In this plant, ignition coils move on electrified conveyors, where they are tested and the results indicated by sight and sound. The coils moving in the conveyor are checked for presence by a photoelectric cell and pass against sliding contacts for successive electrical tests. Sound signals notify the operator of defective coils, which he removes and places in a reject chute. The testing of fluorescent starters has been accelerated by this automatic rotary machine. The starters, loaded manually into a rotating conveyor, are actuated by contacts traveling along a circular track. The starter lights a fluorescent tube within a given period of time, and a photoelectric cell detecting the light allows the starter to be passed. An unlighted tube calls for rejection. Limit switches set and reset relays, permitting proper inspection of each succeeding starter. In packaging, there are increasing opportunities to apply automation principles. Here, a group of machines automatically package nearly 13.5 million gallons of milk a year. The carton flats are formed and glued and then ejected into a wax tank, from which they enter a cooling compartment to harden the wax. The milk already pasteurized and treated is piped into this filling station, where carton after carton is filled with an exact amount. In this case, the capacity of the carton is 2 quarts. Folding and stapling the cover is another automatic process from which the cartons march endlessly to be placed in cases for delivery. The tiresome and relatively expensive work of filling packets with small items like screws or bolts has been eliminated by this packeting machine, which can turn out 24,000 packets per day. Small screws, bolts, nails, or parts are fed from the bowl vibrators, which can automatically start or stop the flow of items, affording exact control of the number of pieces in each packet. The double unit can pack 2 different items at once, ranging from 1/2 inch to 1 1/4 inches in length. Making, inspecting, assembling, testing, packaging. The small manufacturer may not be able to automate every stage of production, but there are numerous opportunities to upgrade one or more individual operations. The volume and nature of the product largely determine whether automation is feasible. Product design, standardization, materials and processes are the critical elements. Where a complete redesigning job is possible, the problem of automatic production can be simplified. In the conventional chair, there are a variety of styles. This chair is made from shaped pieces, in many cases with the aid of hand tools, and finally assembled by hand. Here is a chair of modern design, which is the product of more mechanization. The parts are machine formed. They still require some hand finishing and hand assembly. Now, here is the chair designed for continuous automatic production. A fresh approach to chair design is taken. The hand operations are designed out, and the material is molded with integral color and perfect surface. The higher we progress up the steps to automation, the more the product must be designed for continuous automatic production. Of course, there are always exceptions, and customer preference sometimes calls the turn. For example, customers would not go for machine-cut pretzels. Traditionally, pretzels were hand-tied, and some experts said it was impossible to develop a machine to do the same job. But a way has been found to accomplish the impossible. With pretzel tying machines, which can produce 50 hand-tied pretzels a minute. A battery of 16 of these pretzel tires can turn out up to 384,000 of the twisted delicacies in an 8-hour day. Of course, pretzels are standardized and produced in great volume. Standardization for volume production is one of the key factors in automation. With standardization, volume production, if it cannot be applied to the product itself, may be applied to the parts. The 4 legs of the mechanization area chair might be produced automatically. In low production items such as large motors, the production of the laminations may be automated. In the jet engine, the number of turbine blades is high, and here again, volume offers the possibility of automatic production a step below the product level. There is a place for automation in every industry, large or small. The extent to which it can be applied economically is determined not by the size of the business, but by the volume and nature of the product. In any operation, electricity is the essential ingredient of automation. As manufacturing operations are upgraded through the mechanization area and into the automation area, the vital importance of flexible electrical equipment grows. Equipment like control panels, limit switches, adjustable speed drives. These and many other standardized electrical units available today contribute to automation. More specialized equipment is available where it is needed to automate extremely difficult operations, such as turning and facing cuts on irregularly shaped jet engine parts. The machine is a vertical turret lathe equipped with 2-dimension tracer control. A signal is generated in the magnetic tracing head by the displacement of a stylus against a template. Sensitive electrical equipment takes the low power signal from the electronic panel and amplifies it to the power level necessary to operate the feed motors. In this case, automatic control is a necessity, since the cost of manufacturing such parts without tracer control on the machine would be prohibitive. Another type of control is that made possible by record playback. Here is a mill designed for the machining of integrally stiffened airplane wing skins. The use of record playback control in this operation is expected to double production. After a part has been produced using a combination of manual and electric control and the action in the form of signals from cell-sins recorded on magnetic tape, the tape is played back for automatically producing successive parts. The tape programs the machine's operations. Still another type of control reads punched cards and automatically positions all motions on such machines as this turret press, which cuts production time in half. Sensing position with cell sins, the control detects and interprets punched card information for the direct current motors which drive each motion. Combinations of electrical controls and drives like these now in use, as well as a great many others, can raise many of your operations to the level of continuous automatic production. Progress towards automation is most often a step-by-step procedure. Much standard equipment in use today can be adapted for automatic production. Transfer equipment can be added, as with this punch press. And many new machines can be purchased equipped with transfers, or designed for their addition, like this machine. There are also machines designed for special applications, but which often include a number of standardized units. There are many other types of machines which can be adapted to this way of manufacturing. Automation, continuous automatic production, is a program for today. For it is today that the average of all manufacturing operations, making, inspecting, assembling, testing, packaging, falls in the low mechanization area. And too often, grunt and sweat methods like this account for as much as 50% of production costs. In some cases, practically an entire production process may be automated. But for the most part, the challenge of today is for management and engineers, men with vision, enthusiasm, and imagination, to tackle the job at hand and improve their operations step by step. Any of these steps is possible, and possible now. Anyone who makes anything can find opportunities to apply the principles of automation to his business. And as we respond to the challenge, the electrical manufacturer and the machinery builder stand ready with the equipment and the engineering skill to help your business meet the competitive challenge of today.
In a restless search for new opportunities and new ways of living, the mystery and the promise of distant horizons always have called men forward. First wondering, then searching, then continuing to explore, men have moved on and on, always to find that old horizons opened the way to new horizons. In a search that has continued for centuries, some far distant view, with its promise of the unseen and its promise of the unknown, has forever fathered the impulse to seek for new things in new places. new horizons, roads for men to go places. The accelerating rate of men's progress in all fields of endeavor has paralleled closely our progress in the freedom of movement from place to place. New things to do and new ways to do them. Telephone, electric lights, automobiles, aircraft, all are symbols of better living. New places to go, and new means of getting there. With a growing appreciation of the wisdom of applying the road tax monies to the road building program for which they were designed, highway development is going on at a rapidly increasing pace. Created by the crossing of new horizons, new ways of living and new thinking have laid the foundation for most of what is good in life today, with the promise of more tomorrow. As distant families have become neighbors, and as people have constantly widened their viewpoints while multiplying the number of their contacts, more desires have developed to be satisfied. And with the demand for all of these conveniences and improvements, opportunities for employment of men, money, and materials have increased. And thus the highways of social and commercial developments are widening without end or limit, except the imagination vision of men who do new things. Today, engineers are always leading us higher, widening the trails, while our men of science are broadening all our mental avenues with new activities based on modern pioneering into new fields of research. Men exploring and pioneering for all to follow. Men endlessly seeking something new along the roads of civilization in the great unknown expanses of applied science and scientific research. All the new highways of research and exploration have brought to us more raw materials, new combinations of raw materials, new and greater productivity of the soil, making more plentiful an ever-widening range of goods. And as these goods come down from the farm, the mine, and the mill, progress on all the highways of human activity leads us to more opportunities for employment. An ever-widening range of goods made ever more plentiful, from east to west, from north to south. Our greatest strides in providing more things for more people have been made at a time when the influence of new geographical frontiers was about over. Mentally and physically, we are progressing toward new horizons. To help us get a glimpse into the future of this unfinished world of ours, there has been created for the New York World's Fair a thought-provoking exhibit of the developments ahead of us, the greater and better world of tomorrow that we in Ankur are building today. A vivid tribute to the American scheme of living, whereby individual effort, the freedom to think, and the will to do have given birth to a generation of men who always want new fields for greater accomplishment, and will always find new things for all others to enjoy. Come, let's travel into the future. What will we see? And now we have arrived in this wonder world of 1960. The World's Fair exhibit, modeled with such artistry and skill that we must continually remind ourselves the world we are now seeing is a vision, an artistic conception which may undergo many changes as it develops into the great realities of tomorrow. Sunshine, trees, hills and valleys, flowers and flowing streams. This world of tomorrow is a world of beauty. These eternal things, wrought by God, are lovely and unchanging. 20 years have passed. With new agriculture and industry, with new forms of education, recreation, a new world is constantly opening before us at an ever-accelerating rate of progress. A greater world, a better world, a world which always will grow forward. Man has forged ahead. New and better things have sprung from his industry and his genius. Here is a modern farm. The farmer of 1960 works in greater security, for science and research have helped him to control many of the risks of agriculture. Hours of work have been shortened, with almost universal electrification of rural areas. Fruit trees bear abundantly under individual glass housings. Orchards are protected against disease and insects. Science even influences pollination by artificial feeding. Does it seem strange? Unbelievable? Remember, this is the world of 1960, and physics and chemistry have joined hands with the farmer in helpful friendship. Here are the farm roads of the community. They have been improved and made to flow into great motorways. This superb one-direction highway, with its 7 lanes accommodating traffic at designated speeds of 50, 75, and 100 miles an hour, is engineered for easy grades and for speed with safety. Cars from the farm roads and feeder lanes join the motorway traffic at the same speed as cars traveling in the lane they enter. Here is an aeration plant, purifying the lake water and distributing it for hundreds of miles throughout the countryside. Here is a highway intersection. Highway engineering at its most spectacular. Traffic may move safely and easily without loss of speed. By means of the ramped loops, cars may make right and left turns at rates of speed up to 50 miles per hour. Elevated and depressed are the turning off lanes. There is no interference from the straight-ahead traffic in the higher speed lanes. The motorist of 1960 finds this intersection safe and efficient. The two-directional traffic of the motorway, which merged at the intersection, separates again. The highway surface is automatically lighted by continuous tubing in the highway safety curbing, which evenly illuminates the road surface. What's this just ahead? An amusement park, 1960. Man's progress has brought more leisure for amusement and recreation, bringing them within easier reach of more people. Industrial communities have gone ahead by multiplying the conveniences and comforts of living. Hundreds of comfortable homes for workers. All people benefited by broadening their scope of living, gaining by advanced means of communication and new methods of work. Here is a thriving and prosperous steel town. Notice the furnaces glowing, river and rolling mills. In the foreground is a model airport, an efficient combination of motor, air, and rail transportation in the world of tomorrow. And now we see an enlarged section of 1960s express motorway. Along the ledge of this beautiful precipice, traffic moves at unreduced rates of speed. Safe distance between cars is maintained by automatic radio control. Curved sides assist the driver in keeping his car within the proper lane under all circumstances. The keynote of this motorway, safety. Safety with increased speed. This 1960 drama of transportation progress is but a symbol of future progress in every activity made possible by constant striving toward new and better horizons. Now we see ahead a steep, challenging mountain climb. Here we see a quiet and peaceful religious retreat, seemingly growing from the rocks as it looks out over the lake and foothills. The slower lanes of the motorway wind in and about the foothills. But from this point on, tunnel and cling to the precipitous rock faces. One marvels at its complete accord with the breathtaking scenic beauty of its route. In the valley ahead, a picturesque resort town. Farther on is a canal with a series of flood control locks. And just beyond, a giant mountain lake dam with its spillway, companion buildings, and hydroelectric power plants, providing power and light for hundreds of miles around. The motorway continues through the mountains. Without tedious travel, the advantages of living in a small town are within easy reach, bringing the people who live there into closer relations with all the world around. Over space, man has begun to win victory. Space living, space for working, space for pay, all available for more people than ever before. Over a spectacular suspension bridge, the motorway enters a large city, spanning the navigable river on which it is situated and forming a gateway to the city. A feature of this bridge is the elimination of congestion and the elimination of interference from all the various converging motorways and from all the feeder roads. And now we see a great river city of 1960. 20 years ago, the population of this city was approximately 1 million persons. It is much larger, rebuilt and replanned. Residential, commercial, and industrial areas all have been separated for greater efficiency and greater convenience. A vast circular airport is close to the city, with a giant dirigible hangar. So that it can be turned easily to meet any wind direction, it is resting in a pool of liquid. Outside is an airport with its hangars and planes. There are special facilities for handling sea of the inland airports of 1960. Here is an American city replanned around a highly developed, modern traffic system. The parks of the city have continuity, proper placement. These areas are united into long green strips surrounding each community. Along both banks of the river, beautifully landscaped parks replace the outworn areas of an older day. An industrial docking basin, newly completed, takes care of all the shipping from the adjacent industrial area. On all express city thoroughfares, the rights of way have been so rooted as to displace outmoded business sections and undesirable slum areas whenever possible. Man continually strives to replace the old with the new. A 1/4 mile high skyscraper's tower with convenient rest and recreational facilities for all. On many of the buildings are landing decks for helicopters and autogyros. Rich in sunshine is the city of 1960. Fresh air, fine green parkways, recreational and civic centers. Modern and efficient city planning, breathtaking architecture, each city block a complete unit in itself. Here is an important intersection in the great metropolis of 1960. Elevated sidewalks give a new measure of safety and convenience to pedestrians. They actually double the available width for traffic in the street. And so, we see some suggestion of the things to come. A world which, far from being finished, is hardly yet begun. A world with a future in which all of us are tremendously interested, because that is where we are going to spend the rest of our lives. In a future which can be whatever we propose to make it. Each of us may have different ideas as to what that future will be. But every forward outlook reminds us that all the highways of all research and all communication, all the activities of science, lead us onward to better methods of doing things. with new opportunities for employment and better ways of living. As we go on, determined to unfold the constantly greater possibilities of the world of tomorrow. As we move more and more rapidly forward, penetrating new horizons in the spirit of individual enterprise, in the great American way.
Furness. In all my years with Westinghouse, I've covered some pretty interesting stories, but here is truly the most wonderful and exciting thing I've ever had the chance to talk about. It's the Westinghouse Total Electric Home, a home where electricity does everything: heats, cools, illuminates, launders, preserves and prepares foods, entertains. It even lights a path to the front door with rayescent strip lighting. As visitors approach, more lights go on automatically to say a cheery welcome. Then, when they arrive at the door, a television camera takes their picture to tell the hostess her guests have arrived. When you step inside the Total Electric Home, you step into an entirely new concept in living, organized around electric centers, such as this entertainment center. Electric heating and cooling keep the home constantly and automatically at the most livable temperatures all year round, and keep it clean and healthful too. Sterile lamps kill airborne bacteria, while electrostatic filters remove pollen and dust. The pride and joy of the man of the house is the Weather Control Center, a center that puts you in charge of the electric heating and air conditioning and the electronic air filtering of the entire house. If you like, the temperature of each room in the Total Electric Home can be set individually. And for the amateur weatherman, the control center reports outside wind velocity and direction, outside temperature and humidity, and barometric pressure. In the winter, the press of a button de-ices the front walk and driveway. In summer, an automatic control starts the lawn sprinklers when the ground gets thirsty. Another beautiful and practical electrical center in the Total Electric Home is the Laundry and Home Planning Center. With individual hampers, your clothes are sorted by type. Directly opposite, to save you steps, are the real geniuses of this very last word in home laundries. All you do is load the clothes in this new Westinghouse 1000 laundromat and electric clothes dryer. The remarkable program computer selects and carries out the perfect washing and drying program for every fabric at the touch of a button. It's the first home laundry that can think. Over here is the combination open fireplace and electric barbecue. By touching an electric starter, the host can get the charcoal going and demonstrate his cooking skill. And whenever the family just wants to enjoy a cozy fire, all he has to do is throw on the logs and push a button to automatically lower a protective screen. Cooking is really a joy in the food preparation center. Here you have a refrigerator that looks like fine furniture. For convenience, the upper unit of the refrigerator opens from both sides, and below are handy, spacious refrigerator and freezer drawers. Then, too, there's the miraculous electronic oven that will cook these appetizers in 6 seconds. Appetizers that were prepared from recipes kept in this microfilm file. Thousands of recipes are on file here, and simply by pressing a couple of buttons, the recipe of your choice appears on the screen. The entertainment center of the total electric home is a whole world of built-in pleasure. Never before has so much fun been organized in one convenient and compact area. Fun that the entire family can enjoy together. For the young in heart, a button selects the latest hit record and plays it automatically. Your television screen is easily aimed toward any part of the room. And for a pleasant background of stereo classics, just press for your selections and put them on the Westinghouse Stereo Fidelity set with special speakers that surround you with music. Almost every form of home entertainment is centered here. AM/FM radio, tape recorder, slide projector, games of all kinds in drawers that roll out at a touch. There's even equipment for showing your own home movies, those personal dramas and comedies written, starred in, directed, and produced by you. A sliding wall of the entertainment center conceals a built-in projector that glides out into the room. Then, at the push of a button, the lights lower automatically, a large movie screen comes down, and it's time for the show. Now, let's take a look at the health and beauty center of the total electric home. The center that keeps you feeling as well as you look. Here, and throughout the house, beautiful fashion plate switches control your lighting. Just a tap of the fashion plate and lights are on or off with no buttons or switches sticking out. Overhead, sun lamps shine down to give you that healthy glow. A true sun bath even while shaving or making up. Being beautiful is so much easier here too. There's an electrically warmed mirror that will never fog up. Over here is something truly remarkable. An experimental wall of light. It isn't on the market yet, but when it does go on sale, it will not only illuminate whatever room it's placed in, but also cool the room in summer and heat it in winter. To help maintain that healthy tingle, there's an electric massage table and outside an electric exerciser. You see, the Health and Beauty Center even extends outdoors into the fresh air and sunshine. A sliding wall here in the children's quarters converts one large area into two separate bedrooms at night. During the day, the wall slides back, and this becomes the Child's Education Center. There's an electrically operated planetarium to encourage a study of the stars. The needs of the growing children in this house are provided for mentally as well as physically, with plenty of space to study or play. Slide projectors, the latest up-to-date maps of the world, and a whole host of electrical instruments that help the eager mind explore nature's secrets and, incidentally, help with the homework. Hobbies aren't forgotten here in the total electric home either. They're more fun than ever here in the Hobby Center. Notice how compactly everything is arranged, with tools and supplies that tuck away into the smallest possible space. Everything is accessible at the touch of a button, compactly stored behind sliding walls, and is protected by an electric dehumidifier, which also helps keep the workshop dry. There's even a smaller version of the workshop for the kids. Designed primarily as a model building workshop, it's child-sized to help encourage the fun of building and creating. To complete the home workshop, there's even a paint spray booth. Equipped as he is with the latest in power tools and equipment, there's no job that's too big for Dad to tackle. Of course, Total Electric Living moves outdoors to the patio easily and conveniently. Here's a new idea, a portable power pole that sets into pre-wired locations and lets you use your television or any of your appliances outdoors. If there are insects, the touch of a button provides screened-in comfort. The screens are in place at night, out of the way during daylight hours. There are even wind screens that move at the touch of a button to give protection from wandering breezes. Eating outdoors is better than ever, too, in the total electric home. Here's a food and service bar that can be assembled in many different ways. And because it's topped with Westinghouse micarta, it is stain and beverage resistant, can be cleaned up with a simple wipe of a damp cloth. Set into its micarta top is the electric barbecue, complete with electric starter and an electric rotisserie. There's even an appliance center and a food and dish warmer. In the total electric home, all the conveniences are yours outdoors as well as indoors. But the real heart of this home is clean, safe, electric heating. A home is not totally electric without it. Yes, a new concept in living with the feel of the future is here today in this Westinghouse total electric home. And the wonder of it is, total electric living is not expensive. What's more, total electric homes can be built to fit every taste in styling, any climate, and most important, to suit any price range. As a matter of fact, total electric living is well within the reach of most people planning to build, buy, or remodel. The total electric home is another reason we can say that when it comes to leading the way with new ideas for better living, you can be sure if it's Westinghouse.
America is busy now. Factories hum and millions of men, formerly idle, now work night and day on tanks, airplanes, defense orders. But what about tomorrow? Tomorrow, when the defense emergency is over, can we keep these men employed making goods people need for living? New labor-saving machines will be invented. Must they again throw men out of work? Or can we use the new machines to make more goods, more jobs?
Say, Tom, I just heard a rumor there's going to be a layoff. Think there's anything in it?
We've heard that kind of talk before. Don't pay any attention to it. We've been here for 4 years now. We ought to be good for another 4 years at least.
I sure hope so. Here comes the boss. He looks worried.
I'm as much concerned over laying the men off as you are, Barnes. But I don't see how we can avoid it.
I hate to break the news. Some of these men have been with us for 10 years and more. It's going to be awfully hard on them and their families.
But this decision wasn't reached overnight. The board's been discussing it for months. We have finally decided to put in the new labor-saving machinery. Costs will be lower and production greater.
That will be good news for the stockholders if it works. But there still remains the question of the men.
By the way, how many men are there in Department 5?
64.
64. And I'm sorry to give you these instructions, Barnes, but the machinery will be ordered. It will be delivered next week.
And that means?
The men in number 5 will have to go. I'm sorry.
I told you so, Tom.
High-speed machinery goes in. But men like you and me go out.
Yes, machines come in and men go out. Everywhere the same story. These whirring wheels spinning faster, ever faster. A mighty crescendo of production. They typify a constantly changing industry. An industry that ever seeks to do its appointed work cheaper and quicker and better.
Sent for me, Mr. Palmer?
Oh, yes, Colby. I'm glad you came. That will be all, Miss Warren. Something I want to show you. Look at those goods piled up over there. You know, I'm worried. Let's go back to the office and talk this thing over. We've got to do something. I'm worried. Here we are. We've got the new machines, and they're doing even better than we expected. They've not only cut production costs, but they've increased output over 50%. But we're not selling this additional product. Inventories are piling up. Now, what are we going to do about it?
It seems to me we've got to change our plan completely. The trouble is we've always catered to a fairly small class of customers at a good price. Sales have come pretty steadily and fairly easily. Now that we're increasing production, we've got to put on more pressure, work the territory more intensively.
You mean more advertising? An increased sales force? Additional dealers?
Yes. Start an aggressive selling campaign right away. Tell the people more about the advantages of our product. Use billboards, magazines, radio. Sell the dealers on the plan in advance and have them well stocked. That will relieve our inventories and get the goods into the hands of the consumers.
Well, I'm not sure the plan will work, but it's worth trying. I'll take it up with the executive committee tomorrow. Meanwhile, suppose you work out a rough estimate of the cost of the campaign and let me have it tomorrow.
I'll do that.
A busy day, dear?
So-so. Did you have any luck today, Tom?
Same old story all over again. No jobs, no luck.
Well, never mind, honey. You'll get a break soon.
Alice, there's something I want to talk to you about. Tramp the streets of this city till I know every building by heart. Hey, there just aren't any jobs to be had. It's the same story everywhere. New machines, high-speed production, fewer jobs, and 10 men for every job that can be had.
You're just tired, dear.
Please let me finish, Alice. About a week ago, I wrote to Cousin Martin. I told him what we were up against. So I asked him if he could possibly find a place for us on his farm. Well, I got an answer today. He wants us to come out and live with him. He says I can be of some help to him, and he's sure that Jane could find a lot of work for you to do. We can go right away.
But the campaign advocated by the sales manager fails. The great middle class he sought to reach cannot buy at prevailing prices. People stop at windows, look, and pass by. Yes, the campaign failed. It failed in the city and in the country, too. Let's look in at a typical country store.
Anything wrong with the bill, Martin?
No, it's just a bit higher than I thought, that's all. There, I guess that'll take care of it all right.
That's right, thank you. Martin, how about taking home that gas engine? You want it, don't you?
Sure, there's a lot of things around here we could use, but the price is still too high. And that's one of the things I guess we'll have to do without for a little while longer.
Well, it'll be here when you're ready.
All right. Goodbye.
Goodbye.
Well, it comes right to this, gentlemen. We have made a large investment in labor-saving machinery. It is giving us a bigger output at a large saving in labor costs. The sales campaign was well enough done, I'm sure of that. Our advertisements are appearing everywhere, and our sales force is on the job. But the fact is, we are not selling the additional output the new machines are giving us. Our inventories are mounting, and that cannot continue long if we are to remain solvent.
The truth is, I guess, that the people just can't afford to buy. They can't afford to pay our price.
There's only one thing to do now, as I see it, and that is to reduce our price. This would, I believe, give us a larger market and bring us many new customers who can use our product, but who cannot afford to buy it now.
That doesn't always work. I'm also a director in a food company. I know very well that a lower price doesn't always sell more food.
Reduce your price anyway, Bill. A lower price on some things helps the people to buy other things, and that helps the rest of it.
Maybe, but it doesn't help our food company.
Well, now let's see. Even if the price reduction plan did work, it would reduce our profits drastically and make it more difficult to pay a fair dividend, wouldn't it?
Not necessarily. The profit on each article would be less, of course. But if we succeed in expanding our market sufficiently, we might sell so many more articles, the total profit would not suffer. In fact, if the plan worked out real well, we might even have to buy more machines and re-employ the men who were laid off because of new equipment. Total profits might then be greater.
I'm afraid of it. Price reduction is dangerous. You can reduce prices easily enough, but you can't get them back again to the old level if you have to.
At the same time, I do think the key to the problem is to expand our market. In my opinion, though, that will only happen when we get a little more prosperity and wages go up all over the country. Then most everybody could afford to buy our product.
Why not start the ball rolling by raising wages in our own plant right now? Why bring that up again? It wouldn't be a drop in the bucket. Besides, we'd probably go broke.
Whatever we do, I, for one, am convinced that we've got to expand our market by getting more people to buy our product.
Yes, I know.
Well, I know.
These men are the strategists of business. Throughout this broad land, they seek constantly to solve this puzzle, to untangle the web of prices and buying, of costs and income, of machines and of men. How shall these conflicting factors be arranged to provide better living, more enjoyment of the good things of life, and abundance for all? Find our problem at the crossroads. Broad highways leading in all directions. Which way shall we take?
Ours? Or will our ballistic missile early warning system tell us differently?
7, 6, 5,
Not ours, but theirs.
3, 1.
And if it is theirs, and this is ours? A better design on the drawing board is no immediate effective countermeasure. Our birds must fly when they're required to. The high complexity of modern-day weapon systems demands the closest possible approach to absolute reliability. There is no second chance. So there must be absolute process control during system design and system manufacture. Are these more imports from other lands? Or are they more exports of our own manufacture? Unless we can compete successfully, both at home and abroad, our economy must expand, our industry modernize. To remain strong, to remain free, to enjoy the good life. We also need newer and better aerospace vehicles, and we need them fast.
We need newer and better weapons. And we need to get them from design concept and into operation more quickly and at a reasonable cost. We need new and better products for civilian consumption. Products which can compete with foreign goods here at home or in foreign markets. We must have modern manufacturing, as modern as we can make it. Modern manufacturing is a command performance.
Command performance. Well, we usually have enough command of our process to get the performance we want. Of course, it takes a lot of time to get from a set of new drawings to a finished product.
But time is something we don't always have. The period from development to product is growing shorter and shorter. As someone said, time has collapsed. Now let's try this process. Say the complete product is a Type 20K, and we're changing it with a modification of the Type XR. Now, suppose all you needed to do was to say into a transmitter, 3 Type 20K modification XR.
Orders to the plant.
That's right. You merely define what you want, and in a fraction of the time it would take conventionally, your product's manufactured, assembled, and ready to ship. And that component we were talking about is only one of many making up the complete product.
Well, how could you do all that so quickly?
Not only so quickly, but in much less space. You'd need a much larger plant to do this by conventional methods.
Oh, this is not conventional.
Not at all. This is a modern plant. Really modern.
What do you mean by that?
When you give your command over the mic, which may be in the plant or remote, almost anywhere, the information feeds into a voice converter, which translates your language into a language which the computer can understand. The computer analyzes your request, then draws on its store of information to produce a series of tapes, which feed into a production control center. This center not only controls each of the machines, but the flow of parts as well, acting as a scheduling unit. Now all of the manufacturing units are actuated. Basic shapes are routed to production centers for complete processing. Completed components are then checked automatically by inspection machines, then sent on to a robot subassembler. Subassemblies proceed on to a robot for final assembly, and then on to shipping. That's what I call command performance. Of course, I've oversimplified the process a bit.
You mean you've been putting me on, don't you?
Not exactly. This is not as fantastic as you might think. Take the computer, for example. Computers are fairly common today, although we still must talk to them with cards or tape rather than directly. But they're getting more sophisticated all the time. And from this information, a control tape is produced.
Control tape for what?
To control a manufacturing process. Now, these machines are in existence today. Inexpensive tape-controlled drill presses. The more sophisticated turret drill presses. turret lathes, capable of high-accuracy contouring. Tape-controlled engine lathes. With equally exacting contouring and thread-cutting capabilities. High-precision multi-axis profiling mills. Machining centers that change tools, mill, drill, bore, ream, and tap. In many cases, they can complete the entire manufacturing process in just one setting. Fully capable of doing that job of yours we were talking about, and even more. Now, what different tools would you need for this piece?
6 different milling cutters, 4 sizes of drills, 4 reamers, 6 taps, and 4 boring bars.
And where you needed 8 machines to use these tools, the whole batch is loaded into a magazine for use by this one machine. All the instructions to the machine are on a punched tape. The intelligence on the tape tells the machine exactly what to do. This is called numerical control, which is one of the means of using mathematical definitions to furnish intelligence a machine can understand. There are many methods of accomplishing this. However it's done, it certainly shortens the chain of command and greatly reduces the opportunities for a breakdown in communications. There's the same casting you would have started with in your conventional shop. But notice there's only clamps required. The machine itself will even make its fixtures from tape control if necessary. And there you are. All the machining done in only 45 hours. How long would it have taken in your shop?
Oh, about 300 hours to machine and 26 weeks of lead time.
After you've tooled up. Remember, the lead time here was only 2 weeks. If you need a second or third or fourth piece, you get them in a matter of hours. All exactly alike. Now that's performance.
What happened to automatic inspection you were dreaming about?
That was no dream. They're already in existence too. And research and development are making them better all the time. On this machine, a probe is guided by a tape similar to the one used in manufacturing the part. The measurements are recorded for inspection and record.
But you still need an original detailed drawing, don't you?
Not necessarily. But if you want one, it can be made from a numerical control tape too, operating an engineering machine. Often the drawing can be made at the same time the part is being made, using instructions from the same tape.
I notice the loading and removal from the machine is still conventional.
But it needn't be. You'll find automatic loaders and transfer mechanisms on a lot of production lines today. This automatic material handler remembers every sheet in its inventory and will deliver it undamaged in seconds. This robot manipulator will perform a variety of handling operations. It can be easily taught to load, unload, and assemble parts because of its electronic brain. So you see, we have practically all the elements of our plan of the future. It's just a matter of time before someone puts them all together to make the dream a reality. I don't know that anyone has ever produced a crystal ball on one of these machines, but you don't need to be a fortune teller to realize that our success in aerospace depends upon our national capability to produce combat-ready systems with complete reliability. We must produce first, best, and at the lowest possible costs, which are consistent with reliability and reproducibility. This means that we must be able to manufacture from all sorts of new and exotic materials. It means we must be able to produce structural members with a high degree of configuration complexity. It means we must produce with greater dimensional control. Some large rocket engine inducers, for example, can't be produced to design concept by conventional manufacturing methods. It means that we must produce components which have structural integrity. This aircraft bulkhead was built up of over 90 different parts, requiring more than 1,000 rivets and high-strength fasteners. You can imagine how long it took to tool, machine, and assemble all these parts. And you can imagine the possible human error involved. The more modern one-piece bulkheads have greater structural integrity, but they were still expensive. These one-piece bulkheads were first produced by conventional methods, using specially designed tracer-controlled rotary tables with many coordinated overlay templates and tracer patterns. It took 160 hours of machining time to produce one bulkhead, and at considerable cost. The part is now programmed on a numerically controlled skin mill to machine 2 at a time. This requires only 2 sets of vacuum chucks and 9 reels of tape. The time reduced to only 9 hours per part, and the cost reduced by 80%. In addition, there's a 25% reduction in weight. Command performance? I'll say. But you can best get it with numerically controlled machines.
Can this type of control be applied to other types of machines?
Certainly. There are machines that automatically position and punch all types of panels. Machines which build up rocket motor cases by the controlled winding of glass filament. Machines that position connector panels for wiring. Machines that position and make the wiring connections on assembled electrical panels. Machines for drilling printed circuit boards. Machines for inserting the components in these boards. Machines for spot welding, which saves 72% in labor costs. This machine has proved invaluable in spot welding fuselage sections. The more complex fusion welding also can be performed by numerical control. The tape not only controls the positioning and movement of the arc, but also the welding factors, gas flow, current, and the like. In guiding the arc, the control permits blind welding down through one structural member to fuse it with a hidden member below. The result? A stronger weld, a member with more structural integrity. A more reliable weapon system. Tubes can be bent by numerical control also. Tailpipes that fit any car precisely. Or the miles of plumbing used in modern missiles, and all without the need for separate jigs and setup time. By far the most versatile and flexible are the numerical controlled machines. For one-piece or production runs, they're the answer to involved machining operations. And for machining control, you can't beat instructions which are fixed and not subject to human error or emotion. Why, this tape could be sent anywhere in the world to a similar numerically controlled machine. And it would produce a part interchangeable with the one produced here from this tape.
May we backtrack a moment?
Surely.
Just how do the instructions get to the machine in the first place?
Well, let's begin with your own sketch of some part. Make it complicated. We'll hog it out of a block. Let's use master dimension.
Okay. There you are, with all the essential dimensions, but scarcely something a machinist could work from.
That took you about an hour. Now, we'll take this to a programmer as the next step in tape preparation. And there's the program. Now, let's see, that took about an hour and 45 minutes. Add that to the hour for the sketch.
And the 5 minutes it took us to get here.
And the total's 2 hours and 50 minutes.
Those words on there look sort of familiar, but different.
That's right. They're a kind of pidgin English. This information will command the tool to start from the point called set point, which is defined as the point with coordinates 1, 1, 1. With the tool on the right, it is instructed to go right along the line base. At this point in the operation, the tool is sent forward to start cutting a previously defined circle about a previously defined point 2. Now here's that circle on the sketch. You can see it's a language that you can readily understand and use, and one the computer can understand too. As of now, conventional computers do not accept oral commands, so the instructions are put on punched cards or tape. We're moving right along. Just 10 minutes for that job, for a total of about 3 hours. Now the computer operator gives the commands to the computer, which translates them into machine language. And here are the commands we'll take to the machine. We've now spent only 3 hours and 20 minutes. That's really chopping down lead time, isn't it?
Yes. I expect it would have taken me weeks to design a tool for this job.
It might be a good idea to think about modernizing then.
This whole system's called numerical control?
Well, the machines are operated by numerical control. When you talk to a computer, though, well, that's a little higher order of communication. I suppose you might call it symbolic control at that point. But look, your part is already being manufactured. There's your part. Just 4 hours after you started making the sketch. You want to check it out?
You bet. Amazing. Absolutely amazing.
You see, what happened was that the machine did what machines can do best, and humans did what humans can do best. You did the designing, the creating. The programmer planned the process from his knowledge of machining and the particular machine. And being human, you were able to start a chain of command to the machine, a very short and very exact chain. As a result, you obtained a superior performance from the machine, far better than by conventional methods. And you get the same performance time after time, because the commands cannot change.
And that's why you call it command performance.
That's right.
Well, what about the actual joining, forming, or removal of metal? What's new along these lines?
Plenty. Electron beam welding, for one thing. Here, even two dissimilar metals can be permanently fused together by the high-velocity electron bombardment in its vacuum chamber. Electrolytic machining, for another. The cooling holes in this turbine blade were eroded to exacting tolerances by this stem drill. The hollow drill electrodes never touch the material, so they need not be reset or replaced.
Just the opposite of electroplating, huh?
Correct. This finished turbine bucket was shaped from high-temperature material. And here are the shaped electrodes that were used to do it. The process replaces a dozen conventional machines and produces a yearly savings of about 80%. When subjected to enough pressure, metals become plastic and are easily formed. This vertical shear forger produces turbine compressor shafts at a savings of $1,500 per part. Similar machines will turn out shapes such as cylinders, cones, and rocket motor cases from practically any metal, including many of the exotic alloys. Or suppose your product needs formed parts, like this. This machine pre-stresses metal to its yield point and has a tension control system, so that forming is accomplished with high accuracy. This jet engine part was formed from Rene 41 in just 2 minutes, and the savings over conventional methods is 80%. A similar type of process will give you savings of up to 90% on drawn components like this, and permits the use of inexpensive dies. This blank holder, adapted to a conventional press, pre-stresses the metal and makes it more flowable than plastic. By adjusting the stress, almost any metal can be formed using the same die. Normally, 3 draws would be required to produce this part, with 270 hours of handwork for finishing. But here it is, produced in 1 stroke, holding its shape without springback, and maintaining that shape throughout subsequent welding. This hydroform turns out complex, shaped parts in seconds that formerly took hours to fabricate, assemble, and weld. The rubber bladder reduces tooling to only 1 inexpensive die. Want more savings in forming metals? Perhaps electromagnetic metal forming is the answer. This process uses powerful magnetic fields to swage, expand, compress, coin, shear, and assemble conductive metals without mechanical contact with the work. This machine uses the explosive power of man-made lightning to form parts.
What about forging?
How about that? That's high energy rate forging. These machines will deliver a terrific amount of energy in a split second to forge such materials as tungsten or even cast iron, as well as the usual materials. High-tonnage mechanical presses also offer great savings in the production of precision forgings. For testing electronic systems, there's automatic testing equipment. Here's a complete checkout of a wiring harness. This machine checks missiles, computers, servo systems, and the like. results of the tests can be recorded on a printed readout. And the savings? Well, in addition to the time, this piece of equipment replaces 150 separate pieces of test equipment required on many of the complicated checkoffs. Imagine what all these methods of modern manufacturing are going to do for the designers. And of course, you've seen only a few of the many new methods available today. No need for them to be limited by the restrictions of conventional manufacturing. They can now design a part to do the best job without compromise with manufacturing limitations. I doubt if there's a machinist in the world who could have turned out this part and met the required specifications. Yet it's a vital part, and I know that without modern machining, it could never have been produced in time to get our missiles in operation on schedule. And believe me, we must be on schedule in these areas. We must modernize our manufacturing methods. And go from design concept to finished product as quickly as possible. We must keep the wheels turning the best way we know how. We must apply what we know today and search for ever better methods. This is a command performance for the survival of industry and our country.
Say, do you still have that clipboard?
Sure. Here it is. Why?
I want to write myself a note so I won't forget something. See? This is going to be a command performance, too.
Good idea. Because the Defense Department expects its contractors to maintain a modern base in their facilities. In keeping with the advance of aerospace technology, we need the productivity, reliability, and repeatability that only modern manufacturing can provide. And we all need the savings which can be effected in both time and money.